Hello everyone, welcome back to the channel. Today we are going to understand the placement group as far as AWS EC2 is concerned. Based on various requirements that you have, you can create or you can choose the placement strategy or the placement group. You can create the placement group, and your group of instances will be deployed as per the placement group that you have decided. And what are the various placement strategy that AWS provides? Let's understand that. Okay, so first is cluster placement group. When we say cluster, basically it will be deployed in one availability zone. The first point is very important. It will be in the single availability zones. Your instances will be placed in different racks, or it could be in same rack. Okay, but they will be placed very close to each other, because the main objective of this cluster placement group is basically to have the lowest network latency and highest network throughput. So that's the goal, and based on this goal, it will be placed inside the single availability zone. And the racks, when I say racks, it's basically the rack is basically consisting of many physical servers, and each physical server will have many instances. So there are multiple racks in any data center. So availability zone is nothing but a data center. So it will your instances will be placed in one of these racks, and these racks basically will be very close to each other. That is why you are able to get the highest network throughput. So now the best use cases for cluster placement group, or basically what are the use cases where you would use the cluster placement group. So it's obviously you need high performance computing, like we told, right? The network latency should be lowest. Machine learning algorithms, scientific computing, so they need all this very high performance or very lowest network latency, right? So in such cases, you will see the cluster placement group. Now the second type of placement strategy is partition placement group. So here the objective, right? You just keep in mind the objective, right? For cluster placement, it is low latency and high throughput. Now partition placement is fault isolation between the groups. So you have multiple instances, groups, okay, basically, and they will be divided into groups. The difference, if you compare it with cluster, it can span multiple ACs. It can be multiple ACs. Now there will be multiple partitions created, okay, and each partition can have multiple instances. Okay, so just keep that in mind. Say here I have 12 instances. Okay, just take this example as we see in the diagram. We have 12 instances, and each and two instances, basically they are part of one partition. So these two are part of partition 2. So in this way, these set of two instances, basically they are divided into various partitions. And the limitations obviously is that in any AZ, in one AZ, you can have up to 7 partitions. So that's the limitation that we have with the partition placement. But each of the partition can have hundreds of instances. Okay, so just keep that in mind. Together they can have a lot of instances together. So what is the advantage that we get with partition placement? Like we told, it's excellent fault isolation. Why? Say I have these 6 partitions, right? Say one of the partition goes down, all the other partitions are still working. So you have multiple nodes, or basically multiple instances still running. So that's the advantage. Say the whole AZ goes down, obviously your AZ2 is still up and running. So again, this is providing very high availability architecture and excellent fault tolerance, because you have the other partitions working. And see, in most of the distributed architectures like Cassandra, right, the NoSQL database, or you could say Kafka. Kafka has multiple brokers, right, and these brokers, they are deployed in different AZs, and also they are divided into various partitions, correct? So and the data is duplicated across the brokers, basically, just to make sure that it is fault tolerant. Similarly for Apache Cassandra as well, you will have multiple nodes, and each node basically is working as a replica of each other. So and as well as the Hadoop, etc. So in these distributed architecture, the first of all the duplication and plus the fault tolerance is very important. So partition tolerance or partition placement group basically is the perfect placement strategy for such kind of applications. And you can see that instances are evenly distributed. So you can see that here we have 12 instances and 6 partitions. So they are evenly distributed. You can even launch instances into a specific partition. You can choose the partition. So that is where you will get the advantage for Kafka, etc. Okay? Just keep one thing in mind is you can have up to 7 partitions per AZ. So this is the limit that you will see as far as partition placement strategy is concerned. Now the third type of placement group is spread placement group. In a spread placement group, there are no partitions. Okay. Thing is, all your instances they will be in different racks. When I say different rack, completely different hardware or hardware equipment. So like I told you, every rack can have so many physical servers, and each of the physical server will have the instances. Say I have these many instances, right? Say I have 6 or 7 instances. So what spread placement group will do is it will place only one instance in one rack. Okay, you cannot have 2 instances in the same rack. In cluster, there were chances that you might have 3 instances in one rack. And similarly, if you go in the partition placement, one partition, so it could be like 2 racks, 3 racks create one partition, or it could be one rack creating one partition. But you can have group of instances or multiple instances in that particular partition. But here it is like maximum hardware isolation. So only one rack, one instance. One rack, one instance. So this is the hardware isolation that spread placement group provides. There are limitations as well. So what is the limitation? You can only have 7 instances per AZ. Say suppose there are 21 instances and we have 3 AZs, correct? So when we have 21 instances and 3 AZs in the split placement group, what will happen? 7 instances in AZ1, 7 instances in AZ2, 7 instances in AZ3. Now suppose there was a need for another instance coming. So there you might face an issue. You will not be allowed to do it. So that is the drawback or the limitation, you could say, for split placement group. So you just need to keep that one thing in mind. So launches may fail if unique hardware isn't available. So that is also very important. Like the hardware availability is also very important. Like a rack should be empty, right? Say suppose we have like 6 or 7 racks in an AZ, but say all of them are busy. There are no racks which are available. Basically unique hardware. And like we discussed, right? So what are the advantages? So maximum hardware isolation, and the instances will be deployed on separate racks. So it reduces the correlated hardware failure, right? So one rack, say one whole rack goes down in a particular AZ, only one instance will be down. The other instances will be still up. And what are the use cases? This is important. So the most important use cases is the primary standby databases, like our relational databases like Oracle, MySQL, etc. So you will have the primary database in one rack and standby database in the other. You don't want both the primary and standby databases to be in the same rack. See, if we use partition placement, right, for this primary and the standby databases like MySQL and Oracle or Postgres, etc. The problem is if it is part of one partition, then if that partition goes down, here both primary and standby will fail. So there is no proper hardware isolation. But in this case, we need this proper hardware isolation, and that is why it is very important that they are in different racks basically. So you can have it in different racks, and plus you can have it in different AZ as well. So like one primary database is in AZ1 and standby database is in AZ2. Again, it will be in a different rack itself. And you can obviously for domain controllers for your critical application servers, etc. Your hardware failures are very important, and you need isolation from that. So those are the use cases for your spread placement group. Now the fourth, precision time placement group, this is newly added in the AWS placement group. Now the point here is it is not a kind of what you would compare with cluster, partition, or spread placement group. It is supporting what basically there is AWS comes up with the hardware which actually assist or hardware assisted precision timing. So these are the racks. You could say these are the racks of physical servers which are basically doing ultra accurate clock synchronization and hardware assisted precision timing. So these are specific for the financial trading platforms, scientific computing, etc. They need this hardware assisted precision timing. So that is the reason why this precision time placement group has come up. So your EC2 instances can be launched into these racks, and just important points to keep in mind is that only few supported instance types and families. Obviously, this hardware assisted precision timing won't be available in all the instance types and families. So that is the or cons you could say, or limitation you could say, which is quite logical, right? You cannot have such kind of hardware assisted precision timing or ultra accurate clock synchronization, which is based on the hardware on all instance types and families. So this is and this is for very limited use cases, okay? Like financial trading platforms and scientific computing, space technologies, etc. Now the other important point is precision time placement group. So you can first create a precision time placement group as a parent placement group, and then you can have the cluster placement group as your child. Why do we need this? Because see, in these cases, in financial trading or scientific computing, You want the lowest bandwidth as well, so you want the cluster to be in one very adjacent racks or maybe same racks. That is very important. And plus, you also want this clock precision. So you get both of them together using the placement group. Otherwise, AWS doesn't allow the combination of the other placement groups in any case. Like you cannot have cluster and placement together. You cannot have RAID or placement partition together, RAID or cluster together. It is only possible with precision and cluster. So just keep that thing in mind. We'll just do a very simple comparison again here. We have cluster for low latency, highest throughput that we have checked. Single AZ, just keep that thing in mind. And partition is fault isolation between partitions. You can have up to 7 partitions, keep that in mind, per AZ. RAID is up to 7 running instances per AZ. So this is for hardware isolation, and this is the fault isolation between partitions. And precision timing is for ultra accurate time synchronization. It is specifically for time sync. Now, few more things. You need lowest latency and highest network performance. Go with cluster. As soon as you see lowest latency and highest network performance, right? Obviously, you'll have to see there is a trade-off. There is a trade-off in everything. You want highest latency, network performance. Obviously, you need to give in with some kind of availability or fault tolerance. So cluster won't provide that. But in a very large distributed system where you're okay with little bit of latency or the performance drawback, so your drawback is basically where you need to trade off with the uh, network performance. So, but you want high availability, right? So in that case, or the fault tolerance, highest fault tolerance, then in that case you will go with partition. And in case you are worried about the hardware, you want a single rack to have only single instance, then you go with spread highest, or you could say maximum hardware isolation. Okay. So it could be for very critical applications as well, right? You don't want the two instances to be in the same hardware or same rack. In precision time, we will discuss for the time synchronization or hardware-based precision timing. Now, few rules and limitations. So, like I spoke, right, in instance chain belonging to one placement group at a time, except for the precision time and the cluster that I have explained you. You can have a parent-child relationship there. You cannot merge placement groups. Only 500 placement groups per region. That is the maximum, up to 500. No additional charge. You don't pay for anything for the placement group. You pay a dedicated host basically. They cannot be part of the placement group. Spot instances, again, they are not part of the placement group. And capacity utilization, etc., they can be used. And this is how it is. So what happens? The underlying infrastructure hierarchy, you have the region, you have the availability zone, you have the racks, and racks can have physical host, and then you have the instances. So this is how the underlying infrastructure looks like. And if I go to the console, I will just show you where you can see this. If you go to EC2, and on the left hand side, in the network and security, if you see, look at the placement group here. You can create the placement group. I just really time to see you have the option of cluster, spread, partition, precision timing. And like I told you, precision timing can be a parent. If I just create this, and if I create another placement group, say cluster timing, and if I choose cluster, you will see this option of child, and it will show the parent placement group. So what is the parent placement group? So it is available as time-based PG which we create. You can just create this in this way, and if I choose for trade, etc., you have this option of outpost or rack no restriction, right? This is one thing. And partition, you provide the number of partitions that you want. Just keep one thing in mind: 7 partitions per AZ. If there are more partitions, obviously they will be spread across the availability zone. So 7 partitions per AZ means you can have maximum. Say in a region there are 3 availability zones. So obviously you will have 21 maximum partitions that you can have in that region. Similarly, for the spread, 7 instances per AZ. So maximum instances that you can have in a particular region is 7 into the number of availability zones. So this is what the calculation that you can keep in mind. And as far as where would you see this information, or where you can use this information while launching instance? If I launch my instance, so I'll just show you where you can see this information. Here you can see the placement group. So what we have created cluster time, I can choose the placement group here. So you can even keep it in your launch template, etc. And based on that, your instances will be launched. So this is all about the placement group. Thank you so much. Have a good day.